Hi friends, this is today's POTD of Geek for Geeks, which is easy one. Longest pairs sum. Find the longest pairs sum in an array of distinct integers. Nothing but our array contains distinct integers. It doesn't contain similar elements, right? So, and we have to do it in big of n time complexity and one big of one space complexity. That means we are not allowed to use any data structure. And here constraint size is 10 to the power of 6. That means the possible answer time complexity must be less than 10 to the power of 1. I mean big O of n or equal to big O of n, right? So here 1234, let's understand the given example. So we have an array 12 which contains element as 12, 30, 34 and 10, 6 and 40. And what we have to return? We have to return the maximum sum of the array. So it is nothing but we can sort the array. If we can sort the array, then the for the array at the beginning of the array contains the smaller elements, and in the end of the array it contains larger elements. If we can perform which is sort, ascending order sort, right? But here sort function actually takes time complexity as big of n log n, and we have to use an algorithm which gives the answer in big of n time complexity. So we are not allowed to use the sort for these for this. So now we have to know what is the first biggest element and what is the second biggest element. So it's an easy one, right? So first we have to use a for loop to extract the first maximum number, and then we have to use another for loop to extract the another maximum number, and finally we have to return m1 plus m2, right? So how we can extract the first maximum number? So it's an easy one, right? So first we can assume our first element is the maximum element, and we have to write a for loop from first number index first to the end of the index, and we have to check whether the current index is actually greater than the assumed maximum index. Yes, here this is our assumed maximum index, and whenever it is, we have to change assumed maximum element is equal to current index element, right? So in this way we can get the first maximum, but after that we need to get the second maximum. So that's why we have to uh, we have to we have to make the first maximum as 0. So we just have to keep 0 into the first maximum. Then only when we are iterating the second time, we won't get that as a maximum element, right? So for that, I'm so for that here this is the maximum element, right? So now here what we are doing, we have to make we have to make it as 0, and now we have to use iterate over this array again with same approach, and then we can find the second maximum as 34 and first maximum as 40. We already have first maximum as 40. Now we have to return this. So like it's a simple approach, and the time complexity is like big of 2n, which is nothing but big of n, and the space complexity is obviously big of n because we didn't use any uh, extra data structure, right? So see, let us. Uh, I already submitted the code, so let me open that. See here, I'm taking as this is an array, so we have to find the size of an array. Then only we can iterate up to that number of times, up to the size of the end of the array, right? So in the first iteration, I need to take a max, so that's why I'm assuming that my first element is my max, and I have to write a for loop from the next element to the end of the array, and I have to compare whether the current element is actually greater than the max. Then I have to take that max, and I have to remember that position. Why? Because we have to change the value inside that position, right? So after the this for loop execution is completed, we have the maximum element and along with its index. So we have to keep 0 in that index position, and after that we have to take maximum 2, which is initialized to the first element, and we have to do the same process as we followed for finding maximum 1, and in the end we have to return the maximum and maximum to summation, and it's accepted. I hope you understand this one, and thank you for watching this video.